Hello everyone, welcome to the lecture. Myself Devananda Rao, working as Associate Professor in the Department of CSC, MLR Institute of Technology, Hyderabad. Today's topic is bootstrapping. Bootstrapping is widely used in the compilation development. Compiler is a translator which translates high level language program into low level language program. So, bootstrapping is a technique that is used in the compiler development. Bootstrapping is used to produce a self-hosting compiler. What is a self-hosting compiler? Self-hosting compiler is a type of compiler that can compile its own source code. Writing a compiler for any high-level language is a complicated process. It takes a lot of time to write a compile from scratch. Hence, a simple language is used to generate target code in some stages. Let us understand these lines. Writing a compiler for any high level language is a complicated process. It takes a lot of time to write a compiler from scratch. That means, for example, let us suppose you want to create a new language, programming language called, let us call it as my language. My language is a new language you want to create, but for this language you need a compiler. That means you would start writing compiler. That is simple. Start writing a simple version of the compiler. Of compiler in a language like C, because C is a widely used language and well supported and widely used language. So that you will start writing a simple version of the compiler in a language like C to compile this my language. But a simple version of the compiler is called a bootstrap compiler. A simple version of compiler written in other language like C is called bootstrap compiler. So that you can use bootstrap compiler to compile the source code of the compiler for the language my language. Okay, you can use this bootstrap compiler to compile source code of the more complex compiler you want to create for my language. That means use this bootstrap compiler to compile a source code of more complex compiler for my language. This is new language. So, you want to create a compiler for my language. So, that we need a bootstrap compiler to compile a source code of the more complex compiler for my language. So, that this process will generate executable for new language, for new compiler. So, this process will generate executable for new compiler written in my language. I repeat once again. Suppose first you want to create a new language called my language. For that, you need to write a compiler. So, writing a compiler from scratch is a difficult task. It is a complicated process. So, that you need to use a simple and available existing language like C. So, that by using C language you can write a simple version of compiler in language C. This simple version of the compiler is called bootstrap compiler. So that we can use this bootstrap compiler to compile a source code of more complex compiler for my language. So that this process will generate executable for a new compiler written in the language my language. Okay. So, bootstrapping is a process in which a simple language is used to translate more complicated language, which in turn may handle for more complicated language and so on. Next, a compiler can be characterized by three languages. First one is source language, target language and implementation language. These three languages are represented by using T diagram. T diagram: source language, implementation language, target language. Next, a cross compiler. A compiler may run in one machine and produce a target code for another machine is called a cross compiler. So, let us understand this concept, cross compiler. To clearly understand the bootstrapping technique, consider the following scenario. Suppose you want to write a cross compiler for a new language X. X is the new language. The implementation language is Y. The implementation language is Y. This is implementation language. This is new language X, source language X. Then the target code being generated is in language Z. This is target language. So, source language, implementation language, target language. Source language is X, implementation language is Y, target language is Z. So that we can create a compiler X, Y, Z. Now, if existing compiler, this is existing compiler, Y is the existing compiler. So that now existing compiler runs on Machinium. This is Machinium. Existing compiler Y runs on Machinium and generates code for M. Generates code for M. Then it is denoted as YMM. Here Y is the existing compiler, M is the implementation language, that is Y runs on Machinium and generates code for Machinium. Then if you run X, Y, Z, this X, Y, Z, if you run X, Y, Z using YMM, then we get a compiler called XMZ. That means a compiler for source language X that generates a target code language Z which runs on machine M. In this diagram, you should understand these two languages must be same. These two languages must be same, and these two languages must be same, implementation language and target language. So, this concept scenario will explain the concept of cross compiler. Thank you.